you've completed all 6 questions of the exercise on directional derivative. Now, I'm going to work out these questions. Alright? Question 1. F of xy equals f of xy equals 6 minus x. Oh, by the way, don't need to do that. Let me just copy what I have here and paste over here. Get rid of these. Oh. Paste. Alright, good. So that's our exercise on directional derivative. I'm going to copy question 1. Hold on a minute. Alright, there we have question 1. So here now, I want to find the directional derivative. Right? Now, you have directional derivative in the direction of the vector of the function equal Nabla f, the gradient vector f dot unit vector. Alright? Now, Nabla f, the gradient vector, is delta f by delta x I plus delta f by delta y j. Alright? What is this now? Delta f by delta x is going to be negative 3. This part is going to be plus 15y. Okay. And that's I plus delta f by delta y is what now? This part will be 2 9s 18y plus then this part. Remember, I'm not in the best of health right now. I have the flu. I'll be coughing some of the time. And my voice isn't really doing so well. Alright, so that's going to be what now? It's delta f by delta y. I'm doing 15x j. Now, here I could put in the 1 and 2 at this point. So, therefore, Nabla f, oh no, it should be upside down triangle. Nabla f is equal to, here, negative 3 plus 15 times y, which is 2, I plus 18 times y, which is 2, plus 15 times x, which is 1, j. So that's going to be negative 3 plus 15 to is 30. Same thing as 30 minus 3, which is 27. So it's 27i plus 18 by 2 is 36 plus 15 by 1, which is 15, which is 51j. Alright, that is the gradient vector. Now, time to find the unit vector now. vector. We need the magnitude. Magnitude of u is equal to the square root of sine 1.5, sine squared 1.5 plus cos squared 1.5. But you remember the trigonometric identity that says sine squared theta plus cos squared theta equals 1, right? So it's going to be square root of sine squared. In this case, theta is 1.5, but it doesn't matter what it is. Sine squared 1.5 plus cos squared 1.5 will always give you 1. So the unit vector is 1. So this which we have up here so happens to be the unit vector itself, right? Now, therefore now, the next thing to do is find the dot product. I'm going to find the dot product. So therefore, Nabla f dot unit vector is equal to 27i plus 51j dot the vector itself, which happens to be the unit vector, sine 1.5i plus cos 1.5j, sine 1.5i plus cos 1.5j is equal to, is going to be 27 times sine 1.5 plus 51 times cos 1.5. Alright? Now, do I have a calculator that can use, can go into radian mode? Let's see. Let me put this into scientific mode. Radian. Good. So we have radian mode. Now, just to test it, I know that the sine of 30 degrees is 0.5. So I'm not supposed to get 0.5 when I find the sine of 30 here, because 30 radians equal sine. Aha, good. Just to test it out. Now, 1.5. Oh, that's 15 there. 1.5 sine is 0.997 and so on. And that's multiplied by 27 equals I have 26.932. That's 26.932 plus, alright, let's go back to this now. Okay, so let's clear this. 1.5 cos is that multiplied by 51 equal 3.608 when you round it off. 3.608. Alright, good. And then let's get back to our calculator. That so you have 26.932 plus 3.608 equal 30.54. 30.54. And that is your directional derivative. Now remember, if that's not what you got, there are either two things. Either you made a mistake or I made a mistake. If you see any mistake that I make, let me know. If you got stuck and weren't sure, or you identified what you did wrong, I want you to do it over so that you get the 30.54 for the directional derivative.